And now I'm going to head over to my screen share here. And I'm going to bring up some notes here for you guys. Oh, wrong place. Sorry about that. I'm going to be over at my notes. Here we go. Everybody see that okay?
Yes.
Yep.
Okay, perfect. Awesome. All right, so this is normally how I'm going to start once we're done with the Chem 101, unless there's just something I want to mention about the Chem 101 quiz assignment. But normally what I'll start with are some handwritten notes here. Okay, and normally what I'll do is give a little bit of a skeletal show here. And then what we'll do is we'll kind of fill in. So this is just kind of like working at the chalkboard, sort of my equivalent of doing exactly that. Okay, so I'll be sort of sketching these notes out as we go. So we'll do this for a while, and then in the last, maybe 15, 20 minutes of class, we'll jump back onto Chem 101, get you guys a little more practice with some in-class practice exercises. Now, again, remember those in-class practices are exactly that. They're just practice. They don't count for points. They're just a way for us to continue to work with the material we're working with and just going to get you familiarized more with Chem 101. All right, so we want to start out with something that builds on the significant figures video, which hopefully most of you found and watched and took notes on, and a number of you went into Chem 101 and worked some problems there on Sig Figs, which is good. That's exactly what I asked you to do. But that's going to build into this business of actual problem solving. So this is where we get started with the problem solving aspect of chemistry. Okay, so we're going to start out with SI units and conversion factors. So here's the deal. I can write down a number here. So let's just write down sort of a random number. I'm going to put down like 125. Okay. Now, does that number mean anything to you? Well, at this point, you'd say, no, it's just a number. It's 125. I don't know what it is. I don't know anything about what I'm measuring, what have you. So in chemistry and science in general, in order for a number to be useful, and chances are that number is going to be based on some observation or measurement that we make, I have to apply a unit to it. Okay, the unit gives it meaning, the unit gives it scale. Okay, so I could put, for example, centimeters after this. Okay, so what this now tells me is that somebody made a measurement. Okay, it's a measurement, a length or a distance measurement. That's what centimeters tells me, right? And it's 125 centimeters. Now it also tells me sig fig wise that the measurement is good to the nearest centimeter. So in other words, that number will have 3 significant digits in it. Okay, and I know the measurement's good to that nearest centimeter, which is shown as the 5 there. It's not 125.3. Okay, so the unit there, what does it tell me? It tells me, first of all, what we're measuring. And the second thing is it tells me something about the scale of the measurement. In other words, am I measuring something really big or something really small? Okay, so a centimeter might be appropriate for this specific length. Okay, I could also maybe use a meter for that. So you also know that a meter is going to be a standard length unit in the metric system. And it might be used for something that's maybe a little bit longer, right? Because a meter is bigger than a centimeter. So those are essentially the two things that the unit tells me. So now this number, once I attach this unit to it, has some sort of meaning associated with it, okay? So in the metric system, basically what we're looking at is basic units of kilograms, meters, and seconds. So we call this the KMS system, or kilogram meter second system. So what does kilograms get me? Kilograms is a measurement of mass, okay? We're going to learn a little bit later that mass is the amount of matter that we've got. Meter is your basic metric unit of distance. And of course, seconds is going to be your metric unit for time. All right. And what we're going to find as we move through this is that we can take these base units and we can build out other units from them. Okay, so let's say, for example, I want to look at the area of a piece of paper, right? So how do I get an area out of a length unit? So think about it. How do I get the area out of a piece of paper? What would I measure to get the area in the case of a piece of paper? Anybody remember?
The length and the width?
Yeah, so area is equal to the length times the width, right? So if I look at this in terms of length units, I might use centimeters if I'm talking about a piece of paper. That would be the length in centimeters times the length, the width in centimeters, and that's going to give me units of centimeters to the second power, okay? So a distance unit squared is an area unit. If I want to go out to volume, for example, and figure out, say, the volume of a cube, I could do that because you might remember that the area, or rather the volume of a cube, is the length times the width times the height. And in that case, I might be measuring centimeters by centimeters by centimeters, and that's going to give me a unit of centimeters cubed. So if I've got a volume, chances are the unit for that might be a length unit cubed. That'll be centimeters cubed. Okay, so see how I can take a unit and I can build out other units from it. Okay, so that's something we're going to be doing from time to time. All right, everybody okay so far? Everything sort of kind of making sense? Okay, good. And again, stop me anytime you need to. Anybody back? I hear some rustling back there. Anybody want to ask a question? Okay, good. So let's just look at some real simple examples here, and this will sort of lead into the Chem 101 exercise that we want to do a little bit later. So the first example here is, how many milliliters are there in 0.136 liters? So this is kind of the simplest possible conversion that we can do. Okay, so in order to do this, and basically we're going to do the same thing every time, is we need to generate what's called an equivalent statement. So notice what I'm trying to relate here. I want to relate milliliters and liters. Those are the two units I want to relate to each other. They're both volume units, right? And they're both metric volume units, but they're just different metric volume units. So we need to come up with an equivalency statement between those two units to relate them. And you guys probably know, I'm sure you do, that 1 liter contains or is equal to 1,000 milliliters. Everybody familiar with that conversion or that equivalent statement? Now, in order to make this into something useful that I can use to solve this problem, what I do is I take that equivalency statement and I write it as a ratio. And there are two ways I could do that. I could write 1 liter over 1,000 milliliters. It's one way I could do it. Or I could flip that ratio and I could say, okay, I could have 1,000 milliliters over 1 liter. Okay, just write it as a ratio. And now what I'm going to do to solve the problem is I'm going to pick the ratio that's going to get the units to work. So I need a given first. Okay, so my given over here is the volume that has the amount attached to it, which is the 0.136 liters. So I'm going to write down my given first. Okay, and this is really just here to show you a process. This is a really simple one that you guys pretty much all know how to do. So now what I'm going to do is I'm going to take that given and I'm going to multiply it by my conversion factor, which is my equivalency statement expressed as a ratio. So now, which ratio do I use? The one on the top or the one on the bottom? Well, let the units guide you. Okay, so notice where I want to go in the problem. I want to end up with milliliters. So that means I want to have my milliliters on the top and I want to get rid of the liters. So I'm going to put the liters on the bottom. Now, mathematically, look what happens. Liters on the top cancel with liters on the bottom, leaving me with milliliters. So the units are guiding me in terms of which statement I'm going to use. Okay, so going back to my equivalency statement, I know that there are 1,000 milliliters in 1 liter. Okay, and now I can go ahead and just do the math. So if I multiply 0.136 times 1,000, you get 136. And I'm going to attach my unit back to that. Okay, I always check my Sig Figs. Now, how many Sig Figs do I have up here in the 0.136? Okay, I got 3 Sig Figs there, right? And how many have I got in the conversion statement? Okay, that's unlimited. So back in your Sig Fig rules from the video, you learn that if you have a conversion statement like this, you're going to have an unlimited number of Sig Figs. So I'm going to be left to 3 Sig Figs here. Okay, so 136 mils is your answer. Everybody good with that? See how we did it?
Yes.
Perfect. Thank you. Appreciate the feedback there too. All right, so let's look at a second example. This one's a little bit more difficult because there's just more going on. It says here that a runner is going to cover 100 yards in 9.25 seconds. So what's his speed in meters per minute? Okay, so the first thing I'm recognizing here is that I'm being asked for a speed or a rate, okay, in meters per minute. So notice that I give you a distance covered and I also give you a time, right? And a speed is always going to be a distance covered per unit time. So my given in this case is actually going to be the 100 yards. And I'm being careful with those Sig Figs here. Notice that I put a decimal point after that 100. Just as a question to you guys, how many Sig Figs are in that number? Anybody remember? Three, yeah, because of where the decimal point is, right? So what I got are trailing zeros there with a decimal point at the end. So that tells me those trailing zeros are significant. Very good, guys. So your runner's covering 100 yards in 9.25 seconds. So I'm going to write that down here in the denominator. I'll generally write script seconds like that because my regular seconds done the normal way looks like fives, and I don't like to confuse people with that. So what I want to do is there's my given. It's expressed as a rate or a speed because that's what I'm being asked for at the end of the problem here. And now what I need to do is to get my units to work out. So what I like to do here is I kind of like to pick the numerator first and let's work it out. Once I've got it, let's do the denominator. Okay, so I'm going to put a conversion factor in here. Okay, now I need to go from yards to meters. So this is where you need to have a handy dandy conversion sheet that gets you between metric and English. Now I emailed one of those to you earlier today. I've also put it out to D2L. It's attached to a periodic table, so it's kind of got all the information you could ever want in the next couple of chapters in it. So I went to that table and I looked for a conversion factor between yards and meters, and I found one. Okay, so obviously I want yards in the bottom because I want to get rid of it, and I want meters in the top. And that conversion factor, if you happen to have that table handy that I sent you, is 1 meter is equal to 1.0936 yards. And by the way, you can use that table anytime you need it. You can print it out or just have it handy or whatever the case may be. And it's good to use on quizzes or anything like that.
Where is that at?
I emailed it to you, and it's also over on the announcements at D2L.
All right, thanks.
Yep, so it's there. You've got it. Okay, so yards are good. So now what have I got? Notice what I'm left here with, meters per second. I want meters per minute, so I got to deal with the denominator now. My numerator's good, right? So I'm going to go ahead and stick another conversion factor on here. That's going to get me where I need to go in terms of my denominator. Obviously, I want to get rid of seconds, so I'm going to put seconds up top. What do I want in the bottom here? Where am I ultimately trying to go? It's meters per what?
Minute.
Minutes. I got to get minutes in the bottom. Good, guys. Okay, so how many seconds are in 1 minute? You guys all know that one.
60.
60. Last time I checked, it was 60, right? Okay, so what happens to the seconds here? Well, the seconds are going to cancel here and here, top and bottom. Look at what I'm left with. I'm left with meters per minute, and those are the units I want, okay? So notice how I kind of just picked this thing apart, got at the numerator first, and then once I had the numerator down unit-wise, I went after the denominator, okay? So that's how we work this kind of problem. So I worked this out on the calculator, and here's what the calculator told me. 593.13154. If I'm proper about it, I'll put meters per minute in here. And now I got to go back and look at my Sig Figs, right? So I've got two conversion factors in there. Remember, those basically don't limit us in terms of Sig Figs. So I essentially have to go back to my given. Okay, you guys already told me that the 100 yards, because of the decimal point, has 3 Sig Figs in it. The 9.25 also has 3 Sig Figs in it. and I'm multiplying and dividing. So how many sig figs should be in my final answer?
3.
3, very good. So a lot of times what I'll do is I'll just underline that to show which digits are significant. All right, so then if I wanted to rewrite that, I'd look to the right of the decimal point. I have a 1 there, so I don't have to round up. So I would call that to proper sig figs 593 meters per minute. Everybody okay with that?
Yep.
Yeah.
Yes.
For like an answer, could we just write 593 meters per minute equals 3s?
Yeah, that would be
3SF?
fine.
Is that fine?
Yeah, that's fine. As long as you're giving me
Okay.
the right number of sig figs one way or the other, I'm good with that.
Does the
Yep,
593 need a period at the end, the same as the 100 in the
You could
question?
put one there if you wanted. It doesn't need one. It's just assumed there. But if you put it there, there's nothing wrong with that. But because there are no zeros in the answer, you don't have to put it there. All right. So again, I'm kind of showing you some of the tricks that you kind of need to know as you go here. So here's another one that you might want to look at. And there's not really anything hard about this, but this just gets us between volume units here. So I want to know how many milliliters there are in 2.65 cubic meters. Okay, so we know that a milliliter is a volume unit. Oh, and we also know that any length unit cubed is also a volume unit. So a cubic meter has to be a volume unit. Now, there's one other nice, convenient conversion factor I'm just going to remind you guys of here. 1 milliliter is equal to 1 centimeter cubed. Okay, a cubic centimeter is the same thing as a milliliter. Those two are kind of used interchangeably. Okay, you guys probably all knew that, but I just want to show you that that's just an easy way to get from what looks like something based on a length unit over to something that doesn't have length in it, which is a milliliter. Okay, so let's write down our given here. 2.65 meters cubed is where I am. Okay, and I'm trying to get that over to milliliters. So I can work through the cubic centimeter to do that because a milliliter is the same thing as a cubic centimeter. Okay, so here's how I can do it. One way to think about this is to just think about this in terms of length units, right? I want to get rid of meters, so I'm going to put meters down here, but I want to get it in terms of centimeters, so ultimately I can get to centimeters cubed. Now, in 1 meter, do you guys remember how many centimeters there are? Anybody know?
100.
100, very good. Now, notice when I do this that I'm only canceling out one of the meters. So I'd still be left with meters squared up top, wouldn't I? So really what I need to do to get rid of all the meters, I have to kind of do this 3 times. Okay, now notice what happens. Meters times meters times meters in the denominator become meters cubed. So that cancels the meters out. Now, when I multiply centimeters, centimeters, and centimeters together, what do I get? I get centimeters cubed out of that, don't I? Okay, but I also have to multiply the 100 by the 100 by the 100 when I do this. So now I can go directly to milliliters because I know that 1 milliliter is the same thing as 1 centimeter cubed. Okay, so now my centimeters cancel with my centimeters, cancel with my centimeters cubed there. So now I've got milliliters out of this thing. Okay, now the other way you could have done this, if I just kind of put these 3 guys together, is I could have written this as a conversion factor where I could have 100 centimeters over 1 meter. And then I'm going to take that whole thing and cube it on the outside. Okay, that's the same thing. Now remember that cube distributes inside to the centimeters. It distributes to the 100. And it also distributes down to the meters here. Okay, so I could have written my conversion factor that way as well, rather than writing it out 3 times. Okay, it's up to you how you want to do it, but that's probably how I would do it. But just remember to cube everything inside of the parentheses when you do that. It's the same operation as what I showed you up top there. So when you multiply all this out, I'll write it out in scientific notation. You get 2.65 to Sig Figs times 10 to the 6 milliliters, okay? So that's how essentially we can also build out a volume unit from a length unit and use that as a conversion factor. So that's another thing that you sometimes have to do. So I wanted to show that to you. Any other questions about that one, guys? Okay, good. Last example before we head into some Chem 101. This one involves density, which is something I haven't quite talked about yet, but I'm going to introduce it. But let's just sort of read the problem first. It says here that iron has a density of 7.86 grams per milliliter. I could also write that as grams per cubic centimeter if I wanted to. And I want to know what is the mass of an iron block which has dimensions of 2.38 centimeters by 3.15 centimeters by 1.26. So basically I've got a length times a width times a height. And we know how to get volume. Length times width times height give me the volume of the iron block, okay? Now, let's go back to this business of density. Now, density is usually shown as a capital D. You can also sometimes see it as a rho. A lot of times in lab, it shows up that way. It's not a P, but that's sort of a lowercase rho, which is a Greek number. And it's defined as the mass of a substance divided by the volume of that substance. Okay? And if you take a look at the units there, it's in grams per milliliter. So it's always going to be a mass unit divided by a volume unit. Okay? And that's what we get. Now, what does density actually mean? What's property of the substance, right? So a way for us to characterize a given substance like iron. Okay, and what it really means is that's the mass of that substance that occupies a specific volume, like a milliliter. Okay, so in our example, density of iron is 7.86 grams per mil. So that tells me that 1 milliliter or 1 cubic centimeter of iron has a mass of 7.86 grams. Okay, now water will have a different density. Gold will have another density. So density becomes a property of that specific substance. Okay, whether it's an element, compound, whatever. Okay, but I can use density here as a conversion factor. Okay, so that's why we introduce it in this case. It's a good conversion factor for a given substance to get us between mass and volume. So if I have a volume of a substance and I need to get to a mass of it, density is the way to go. Okay, and we're going to see that in this specific example. So the first thing I'm going to do is I want to calculate the volume of the iron block because I'm trying to get to a mass of it. And I'm going to use density as my conversion factor to do that. So we have everything we need to get the volume. The volume of the iron, I'll call it Fe, which is the chemical symbol for the element iron. So it has the length times the width times the height. So that's 2.38 centimeters times 3.15 centimeters. I have it already written up top there, but we'll rewrite it here. Times 1.26 centimeters. So you can see what's going to happen. I'm going to get centimeters cubed out of this, which is a volume unit, which is the same as mils. Okay, so when I do that, I get, the calculator tells me it's 9.44, and I'll throw a few more digits in here, 622 centimeters cubed, which is the same thing as milliliters, okay? Now, let's just check our sig figs as we go here. Looks like I got 3 sig figs in each one of these numbers. So if I multiply them all together, how many sig figs do I have to have in the final answer?
3.
3, very good. So I'm going to go ahead and just underline the 3 sig figs. Now, here's the deal. We don't like rounding error. So even though I've only got 3 sig figs in that thing, when I go and use that, okay, as my given in the problem, I'm going to keep all those digits, but I'm going to keep the 9.44 underlined to show that that's how many sig figs I'm carrying through. Okay, so now I'm going to go ahead and use this as my given in my conversion. So I'm going to write 9.44622, underline my 3 sig figs here. I'm going to go ahead and call that milliliters, which is the same as a cubic centimeter. And now what I can do is I can use my density as a conversion factor to get to mass, right? So I know that I want milliliters in the bottom because I got to get rid of it. And I want grams in the top because that's what I want to end up with as a mass. Oh, and that looks like the density directly, right? Because we said that in 1 milliliter or cubic centimeter of iron, I've got a mass of 7.86 grams. Okay, and that's got 3 sig figs in it as well. So now I'm going to keep all those digits in the milliliters, the 9.44622, which my calculator gave me. I'm going to multiply that by 7.86. And I now have 74.247. That's what the calculator gives me, 289. And that's going to be grams of iron. Okay, let's review sig figs. We said we're bringing in 3 sig figs from the volume measurement. Oh, the density is also based on a measurement. Looks like I got 3 sig figs there and I'm multiplying. So how many sig figs should I have in my final answer here?
3.
3, very good. So I'm just going to go ahead and underline that. I could rewrite this if I wanted to as 74.2. Look to the right, there's a 4 there, so I don't have to round up. And that's going to be grams of iron. Okay, so that shows how I can use density, which is a property of a substance, also as a conversion factor. Again, in this case, to get me from a volume of the substance to a mass of the substance. Everybody okay with that?
Yes.
Yeah.
Excellent. So these again are some fairly simple examples that we can look at. And again, I'm going to post this all up to my YouTube channel. So if you want to go back and review or look at this, any of this again, we can certainly do that. For now, what I want to do is pop over to Chem 101. So for those of you guys who have Chem 101, let's pop over there. Everybody else, if you don't have it, just sort of watch and learn. So I'm going to keep screen sharing here, but I'm just going to go over to my Chem 101 page here, which I have. I just have to go find it. There it is. And we're going to go over here to my in-class problem. So we're going to look at unit conversions number 1 here. So I'm just going to start it. Okay, and it should just go over there. And I think I can just click on it here. And here's what the problems look like. Now, some of these problems, we'll just look at one of these here, this very first one. All right. And I think what I want to do is show the question here. Yes.
Are you
This is
going
one of
to
those-
publish these?
What's that?
Are you going to publish the questions, the practice questions on Chem 101 so I could do them while you do them as well? Or am I
Yeah,
just
sure,
watching?
sure. You should, do you see them right now? You should actually see it on my screen right now.
I see it on your screen right now, but I'm on my Chem 101 on my
Okay,
computer.
yeah, you just follow along. Yeah, that's perfectly fine. Okay, so notice this is one of the things that Chem 101 does sometimes in this kind of problem is it kind of lets you build these conversion factors out. So this kind of confuses students from time to time. So I just kind of want to make sure that you know how to do this. So I figured we could kind of look at this one together. The way they do this is that you want a given first. And notice it has stuff down at the bottom that you can kind of click and drag. So I can take my finger and put the 14.5 up here as my starting amount. And that's gallons. So I find gallons. Here's my unit. And I stick that up here. Okay. And now I need to have conversion factors. Now I may need one. I may need more. So I go back to my, I'm trying to get to liters, right? I want to get the size of the tank in liters. So basically a gallon to liter conversion. Now, if I go to my table of conversion factors that you guys have, I don't think I saw a direct gallon to liter conversion there. So we're going to have to go through some other route to do this. Okay, so one way we could do is we can go from gallons to quarts. And I think in there's a quarts to liter conversion you can use. Okay, so our first conversion is going to have to get from gallons to quarts. So I'm going to grab my gallons and stick them up there. And I'm going to have quarts up top. And notice they give me quarts as an option here. So they've already sort of foreseen this problem arising. Okay. Now in 1 gallon, I'll go ahead and put the 1 gallon in there. How many quarts are in a gallon? Anybody remember?
4.
4.
It is, it's actually 4, and they give you that option there to stick a 4 up there. Okay, so notice what happens. The gallons cancel out. I'm left with quarts, but I want to get to liters. So I need to have another conversion factor. So see down there where it says you can add factor? I'm going to click on that and it'll put a new one in. Okay, so now let my units come around first. I know I want quarts I need to get rid of. Liters are going to be in the top because that's what I'm trying to get, right? And now I go to my handy dandy conversion table here. And one of the conversions I have, well, I guess I got the wrong one there, but that's okay. I think the 0.9463 one is right. So I think it turns out there's 0.9463 liters in 1 quart. I think that's right. I didn't write it down. Anybody got the conversion table in front of them? I think that's right. Because 1 liter is 1.0567 quarts. So that should be the correct one. Okay, so it's all there now, right? So at this point, you've got it. You can set up your answer. There it is. And basically what you do is you just go through and you do the math here and you plug an answer in. So liters are going to be your final unit of volume here. And then you can just do the math here. It's 14.5 times 4 times 0.9463. And one of those options ought to actually be down there as the answer. I didn't work it out, but that's kind of where you're at. So if you run into that kind of problem on Chem 101, that's how you run in, that's how you work it. So you should be able to stick your answer in, so show answer, and you're good. Okay, so I just wanted to show you how to do that because sometimes I know that confuses students in terms of figuring that out. The other kind of problem that you run into here is just working through it on a piece of paper, and it just asks for an answer in the unit.
Hello.
Gotcha.
Yeah, is our does our conversion sheet have like liters to gallons and stuff like that? Like
let me go look at it real quick. It doesn't have gallons directly on it. I think it goes between quarts and liters. I have it here. I can go look it up. It's in my files here. Pretty sure there aren't any gallons on it. Otherwise, I would have just used that directly.
okay.
I think it's just liters and quarts, and I think it shows it to you both ways. There it is. Yeah, and volume units, I see liters and quarts, quarts to liters. Looks like cubic feet going to liters. And it looks like tablespoons and milliliters. That's what you got. So sometimes you just have to work with the ones you've got here. And that's why I added that extra conversion factor for you. Okay, so I just kind of wanted to show you that. All right, so you've got some time to work some of these other problems and just see how you do and talk to each other. It's perfectly okay. You can unmute, ask me, talk amongst each other. That's the beauty of doing this. It's meant to be interactive and, you know, do your thing for the next few minutes and let's just see how we do. And I have you timed in for like another 19 minutes, you know, so even after class, if you want to keep working on it, you're welcome to do so. But again, just practice here. So work on it a little bit.
There's no practice problems on Chem 101 for me.
Oh my. Yeah, we'll have to work that out. I'll show you where it is. If you go back, do you see my screen there? See how I have the in-class tab clicked there?
Yeah.
And I have chapter 1 in-class problems.
Mm-hmm.
Okay, you should be, and it should just actually come up if you hit the in-class tab. Again, if I go back and look at this as a student, do the student view here. Okay, if I go under the practice problems tab, the only one that shows me is unit conversions 1, because that's the only one I've opened up for you guys to do.
Oh, I found it. I was under the wrong tab.
Yeah, it's finding the right tabs. You got a quiz tab, you got an in-class problems tab, and you got a homework tab. Those are the 3 main ones you're going to be using. Like I said, it's intuitive once you've used it a little bit. the other cool things we can do is we can kind of show the results here as we go. So I can pop over and see that 31 people got the first one right because we kind of did it together. And that's kind of nice too, because if there's one you guys are having trouble with, we can always go back and revisit it. Okay, looks like you guys are making progress on all 5 of them. That's good. And again, there's no penalty if you don't finish them. So it's just working along and seeing how far you get, guys.
Are these graded or no?
No, just practice. No pressure.
So, okay.
Professor, could you just go over question 3?
Sure, be glad to. Yeah, let's take a look at it together here, guys. All right, so it says an irregularly shaped piece of aluminum, Al, has a mass of 50 grams. So what's the volume in cubic centimeters if its density is 2.70 grams per cubic centimeter? Actually, if you want, I can pop back over to notes and we can set it up. So let me just pop out of here real quick and go back over to my notes. Okay, so I don't have it here in front of me, but throw me what the I'm giving. And I know we're trying to get to a volume, right? Okay, and we give it a
Yeah.
density of aluminum. What was the density? Somebody want to just call it out?
It's 2.7 grams per centimeter cube.
It's grams, okay. 2.7 was it? I could probably,
Yep.
okay, awesome. And then you also had a mass, right?
Yeah, the mass is just 50 grams.
50 grams?
Yep.
I can probably look it up here real quick. I have two screens I can play with here. That's kind of nice. Okay, so let's do that. And it was number 3. Okay, I got 50.0 grams of aluminum, and I've got 2.70 grams per cubic centimeters, my density. Okay, and I want to get to a volume. All right, so my given in this case is going to be my mass. So I'm going to write that down, 50.0 grams, and I'll go ahead and put aluminum here so I know what I'm talking about. So now I need a conversion factor that gets me over to volume. So density is going to be that thing that relates mass and volume for me. Okay, so I'm trying to get to a volume. So I know I need to have a volume unit on the top, and I need to have a mass unit on the bottom, right? Now, if I look at my density, where does the 2.70 go? Does it go with the grams or the centimeters cubed? Well, it says that I've got 2.70 grams per 1 cubic centimeter of aluminum. Everybody see that? Okay, so now look what happens. Grams of aluminum will cancel with grams, and then I can just work that out from there. So 50.0 divided by 2.70, whatever that turns out to be, and actually gives me the answer here. It's 18.5 centimeters cubed. Now, there's another way you could have done it too. I'll show it to you. You can use the density equation if you want. Remember that density is equal to mass divided by volume. And you're trying to get to a volume. So you could just solve the density equation for volume if you want, right? So if I do that, volume is going to equal to mass divided by density, correct? If I get volume by itself. And then all I got to do is plug in my mass, which is what, 50.0 grams, and divide that by the density, which is 2.70 grams per centimeter cubed. And if you do that, you're going to get the same answer, and the units are going to work out. Notice what happens. Grams will cancel with grams. Centimeters cubes becomes the bottom of the bottom, which flips it to the top. Okay, so everything works the same way. Okay, so you can really do it either way, whichever way is more comfortable for you. Make sense?
Yep.
Awesome.
Yep. Right. Thank
All
you.
right, so we're there. Just a couple reminders here before we go, guys. Make sure you watch the next video for Wednesday. That's temperature conversions, second video. And then we're going to have a quiz with Chem 101 first thing on Wednesday. Same rules apply, but this one's going to count. Okay, so make sure that you're signed up for Chem 101 if you haven't done that and you're practicing with it, and you'll go watch that video. And keep on working on the homework, guys. It's good practice, so you know what Chem 101's looking for. Any other questions?
Professor, where can I find the link to YouTube channels in your syllabus?
Yeah, there's actually a link directly to them in my syllabus. And once you're there, you can navigate around to the correct playlist.
Thank you very much.
You're welcome. Anything else, guys?
Is the video already posted?
Not today's, but like the one we do today, that one will get posted after class. But as far as the videos you need to watch to get ready for the next class period, those are already over there in the playlist. It's the Chem Bonding playlist is the one you want.
Okay.
And then there's the Chemical Bonding Spring 2021, and that's where the lecture videos, like what we're doing right now, go.
Okay.
Make sense?
Yeah.
Perfect. Okay, any others, guys? All right, I will see you guys on Wednesday then.
Thank you.
Thank you.
So, Dr. Richardson, I had an issue with the Chem 101 quiz. I don't know if this would happen more often, but whenever I opened up the quiz, it literally gave me like 2 minutes to do it, and it wouldn't let me submit any of the problems.